Took a tumble with the SkeeRide 2 here. Broke the ski. I'm going to weld it. So, show you how I weld 3D printed parts versus reprinting them. One thing is good. It's a clean break like they usually do. And there's no missing parts, which that wouldn't be a problem in and of itself. But I'm going to start off by welding it in place to get perfect alignment. But the key to welding is to spot weld to start off with so that you get that perfect match using that brake, aligning that brake up. So I'm going to use this soldering station, and here is the tip that I use, and I'll set this at same temperature as my printer, 215 degrees Celsius. So we'll let that warm up and get started. Before I get started, I want to talk about several keys to making a weld on this PLA 3D printed part so that it's as accurate, welded accurately, and as strong as a new 3D printed part. Initially, I want to spot weld it several places and get it attached or bonded and get my original accuracy of the positioning of the brake. So I'm going to spot weld with this tip. I'm going to first tack weld it while it's bolted on to the spindle, and then I'm going to take it off the sled so I can do it from both sides, and then I'll eventually get full penetration by going in with this tip from both sides, and I'll do a full weld. I won't do the full penetration weld from both sides until I get it tack welded for the accuracy. So that 215 degrees Celsius, that's the temperature that I print this PLA plastic. That's what this is, PLA. So by setting that at that temperature, I'll get as good a bond, but also I won't burn the plastic and lose any of the properties of the plastic. So let's get started with the actual tack welding of the part. So I'm looking right back here. I got nice alignment. I'm going to go in here. I'm going to penetrate with this tip of this welder. Just slowly push it in. So I just push on it. Takes a bit for the heat to soak into the plastic. And then I'll take that melted plastic that pushed out and I'll push it back into that spot weld that I just made. So I'm going to continue down both sides of this, do the spot welds probably every ½ inch or so. And then I'll be able to take it off the spindle and I'll show you what I have at that point. I've got my spot welds all on the bottom here. I have a row of spot welds down this side. And what I've done is I've marked the brake with a pencil. On this side it jogs up. And then I have brakes across these shapes right through here. The reason I mark it with a pencil is that fit is so tight that you can't even see where the brake is with it tack welded on now. But I want to stagger my tacks. I'll do like row of tacks here, let that coil skip over here. I'll just keep skipping all around and I'll tack weld it. I also got 4 tack welds on the inside before I took it off. Reached in there and did these 4 tacks just to keep it from pulling out this way, but I can see by the brakes are nice and tight. And so with this tip, I'm going to go halfway through from each side, so I get full penetration. If I keep staggering my welds, the rest of the part where I'm not welding is cool, so nothing will move. Using that same temperature that you print with PLA at 215 degrees Celsius, it won't adversely affect the plastic. The strength of it won't make it brittle. It'll be as strong as the original print. I'm going to go ahead and do some more welding, and I'll off camera, and I'll show you what it looks like. Now I have this entire side starting across the top here, down along this brake, along the whole bottom, up this crack here, and across the top, all welded with halfway penetration through from this side. So now I'll go around the inside, both sides. This other side, I'll get that all welded up, and then I'll talk about how to smooth everything out and make it look pretty so you can't even tell it's been welded. I got it welded around these ribs all the way down this inside and up this brake here. So that's done inside and out. This rib right here. So now I've started here. I'm working both ways. Keep moving out, letting it cool. I'm going to try to demonstrate. I'm going to start working out this way and keep working out this way. I'm just going to try to demonstrate alternating here and here on the bottom. So I'm welded to here. Here's the tack, here's the tack, here's the tack. So I'm welded solid all the way across to here. So I am just slowly letting it penetrate. So not only am I melding that plastic that's touching my tip, but it's putting some heat into the parent material, causing the plastic to rebond. So I'm not burning up any plastic at 215 degrees Celsius. I'm just displacing it. So you'll see it squish out around the tip. And then I'm simply pushing it back in there. And I'm letting it cool as I'm doing this, because I have the majority of the tip withdrawn or pulled back out of the hole that it made. So right when I pull it out, I don't want to void down in there, so I start pushing it back in. What squished around the tip didn't go anywhere, the plastic's still there. Now I'm going to come over here. I've welded up to here. So I'm going to just enter right next to it. Like I said, I'm going about halfway through this rib. See it ooze out around there, and I'm right away as I'm pulling it out, before that has a chance to cool and make a void, pushing it back in. That's already cooling because I'm just pushing it back in. I'm pretty much taking most of the heat away. Move over, do it again. Pull it out, push the material back in. So I'll go ahead and get the rest of this welded up off camera. We'll take a look at what I have. At this point, I have it welded completely inside and out. Checking my fit. Screw goes in, and I could run it like this. The integrity of the ski is now as strong as it was when it was initially printed. I'm fully confident in that. But now let's take it off and talk about prettying it up. Make it so you can't even tell that it's been welded. First thing I'll do is I'll take the side of my tip on my soldering iron, And I'll just start drawing it across here, smoothing it out. So I'll go around this weld and smooth out as much as I can with the tip. What I'm doing is I'm matching it up. I have printed surfaces next to the weld, so I am blending it to those printed surfaces. And then we'll talk about, I have angles on the print. I got these ribs, so lots of ways I can clean this up and not lose any of them shapes. If you muck up any of these little features, like these tiny ribs here, especially down in here where I've welded on them, okay, it's better to, I'll take this filament and just add some material, melt some filament onto it, build it up, and then shape it, carve it with a number 11 X-Acto, or file it or sand it, versus trying to shape it with this tip, because it'll just kind of melt away from the tip. So you can see where I've smoothed along that right in through here. Just kind of blending it down to the original print. So there's the ski smoothed out with the soldering iron on the insides and the outsides. And now I'm going to sand on it some, and then I'll hit it with a torch like this to just kind of blend it in. Now I've sanded the flat surfaces, sides and the top of the ski, with a sanding block, fairly coarse sandpaper. I think it's like 120 grit. That will almost give it the look like it was printed. And I went in between all these ribs and shaped them with a number 11 X-Acto. Got nice, clean, sharp ribs and angles. So I'm going to hit it with the torch and get all this white off from sanding. See what it looks like. And there is my plastic welded ski. Repairs complete. So, two things. This saves on printing time, but then also if you have a part on your sled that it's going to take a lot of disassembly, taking it apart to replace it. A lot of times you can weld it, like when I did the tunnel, cracked the tunnel, I didn't have to take it apart, just weld it in place. So it's a way that works. Just thought I'd share that. Welded her up instead of printing a new one.